The last thing we'll be talking about in right-angled trigonometry is the 3D solids, because most of the times we have to figure out the right-angled triangle inside any three-dimensional shape. We have in front of us a three-dimensional shape. Let's say that we want to find the length of AG. The length of AG is unknown. Given that I know that this side is 3 centimeters and this side is 3 centimeters and the side CG is 4 centimeters. Now, in order to find AG, it is very important to take out the right angle triangle out of my three-dimensional shape. So the needed right angle triangle would be this one. A, C, and G. And this angle is 90. But unfortunately, I don't have AC, neither I have AG. So I can't find AG directly from this right angle triangle. So I need to use the triangle ABC at first to find the side AC. So using Pythagoras and knowing this angle is 90 as well, AC squared is equal to AB squared, which is 3 squared, plus BC squared, which is 3 squared. In order to find AC, I can use the solver on the graphical display calculator. We go to menu, I go to equation, and I go to F3, which is the solver, and I. Instead of the AC, I add x squared is equal to 3 squared plus 3 squared. And I execute and I press solve again. So I'll be having AC to be 4.24 centimeters. AC is 4.24 centimeters. Now I know that AC is 4.24. Now I can use the triangle ACG in order to find the length of AG. Also, I will use Pythagoras again, having AG squared is equal to AC squared plus CG squared. So AG squared is equal, AC squared is 4.24 squared plus CG squared, which is equal to 4 squared. Now, to find AG, I also use my graphical display calculator. I go to also the solver, but let's clear it. Now I have AG squared, which is x squared, is equal to 4.24, all of it squared, plus 4 squared. And execute. So, the length of AG would be 5.83 centimeters, rounded to 3 significant figures. So, this is equal to 5.83 centimeters, rounded to 3 significant figures. Let's have an example now. The diagram shows a cuboid having the vertices A, B, C, D, E, F, G, and H. We have AE to be 5 centimeters. We have EH to be 4 centimeters and AG to be 13 centimeters. We want to calculate the angle between the line AG and the base. Always, when we want to find the angle with an inverted line on the base, we take it with the diagonal of the base. We take it with the diagonal of the base. So we have to draw a diagonal extending from E to G. This would be a 90 degrees angle, and I want to find this theta. Now, in order to find theta, I will use the trigonometric ratios. I know that AG is the hypotenuse. AG is the hypotenuse, and the side opposite to theta, which is AE, is the opposite. So I will use sine theta. So now, sine theta is equal to the opposite, which is 5, over the hypotenuse, which is 13. So theta is equal to sine inverse of 5 over 13. So theta is equal to, we go to our calculator and we go to menu, run matrix, shift sine into a bracket, 5 over 13. This will give me 22.6 degrees. So the answer is 22.6 degrees. It is very important that you have very good skills in dealing with any three-dimensional shape, especially in figuring out the correct right-angled triangle inside it.